There are a few things I still want to talk about the class. The online homework had some questions about how to create your account. So I went through it with a few students, and it did end up costing $100. Sorry, they upped the price. I still think it's a good tool for getting practice through the semester. So we're going to still use WebAssign. And when you create your account, you select the first option at the top that says homework, and then it says it costs $100, but then you can choose a free trial to get started. I haven't put any assignments in there yet, but I will hopefully have one there tonight. I do have the welcome back quiz. I think we'll look at it together. It's on Canvas. It's not graded. You should see the home page. So here we're at the home page, and under week 1 is a welcome back quiz. It's also under the quiz tab. So you can click on your welcome back quiz. Please try to complete this by Friday so I can grade it over the weekend. It's an assessment quiz. It's just for practice. Try not to use a calculator or book. Simplify all of your answers. If you have trouble typing your answer, maybe visit me in office hour or just do your best. And then this quiz is not part of your grade. There's 12 questions. If there's a question that you don't know how to answer, please don't leave it blank. Write something like, I need help, or I kind of remember half of this, but not all of it. Write something to me that lets me know how you feel about that question. Okay, so there's the homework and the quiz. And I think we're going to do notes. Any questions?
Oh, sure. I just started the quiz. Oh boy. So, oh wait, I think there's like infinite attempts, so I could like do it another time or something.
Yeah, that's a good point. On Canvas, I don't think there's a save for later option, but if you need to just try the quiz again, maybe have some scratch work, and then when you reattempt, you can put in your answers and then continue putting in answers. Okay, so we were talking about sets of numbers. I'm going to start to draw that picture we had, and then we're going to cover the complex numbers and then start to talk about functions. I want you to understand the basics of a function because we're going to work with functions throughout the semester. And actually throughout calculus, you're taking the derivatives of a function, integrals of functions, and you're learning about special functions to do those things too. In particular, when you go to your next class, Calc 2, you'll learn about sequences and series, which are special kinds of functions. So we had, the whole numbers to start. Natural numbers start, and then the whole numbers. So that's the set of numbers that you can count on your fingers. This is the same set, but you also have 0, just one more element added to the set. And then we went into the integers, which is the negatives of counting numbers, 0, and then the positives of the counting numbers. And then we are in the rationals, which are all numbers that can be written as fractions. And the irrationals are numbers that cannot be written as fractions, like I mentioned pi and e, and there's the square root of 2. It's called q complement. By unioning this set of numbers that you can write as fractions with the numbers that you can't write as fractions. Those are all of your real numbers.
I think I missed from yesterday. What's that L with the C on the top, and what's that L in the circle again? Oh, I'm sorry. What's the L in the circle? What does that mean?
Let me see, this one?
Yeah, and the other one as well.
Okay, this one, this is a capital Q.
Oh,
I know it looks kind of like L, maybe more like this.
oh, much better.
Q, okay, thank you. Okay. So it's capital Q,
Mhm.
and it's rationals.
Rationals and irrationals.
Yeah, Q
Okay.
complement.
Okay. Yeah.
And then your reals. And then the next popular set is called the set of complex numbers, which we left off at last class. Capital C with a bar. And those are all of the numbers that can be written as A plus BI, where A and B are real numbers, and I is the square root of -1. So they're called imaginary numbers. It's just a name. The name imaginary is just a title. And they are numbers. They're just called imaginary numbers that look like this. Okay.
Wait, is I like the variable, or does that actually like mean a number?
It means a number, that number.
Okay, okay, I got it.
Yeah, good. Kind of like how E is a number.
Oh, like E, like, oh yeah, like E, what's E called again? I forgot.
E is just called E. E. I don't think it has another name.
I think E has a name.
If you use E in your function, then that function is called an exponential function. Oh, it's Euler's number. Nice. Okay, thank you. I did not know that. Euler, E-U-L-E-R. Thank you.
Is this still just review, or are we on? Okay, perfect. Thank you.
2.7 something, something, something. Yeah, it's probably, actually, sorry, Euler is wrong. Euler. His name is Euler, and I'm pretty sure he was a French mathematician, and he has quite a few popular theorems and results that are used in different math books or stats books. Or I taught a little piece of something called graph theory, and he has results for graph theory too. So Euler is a popular math person. Okay, so we're still doing the review. I want to talk about functions, and we're going to start with this. So we start with a relation. A relation is like a relationship. It's a rule of correspondence between two quantities. Going through a bit of definitions. A function is a special kind of relation in which the rule is that every input x has only one output y, or it's also called f of x. So I might bring this up a little bit today, but I mentioned last class that we stick in the real numbers for Calc 1 and Calc 2. So if I have a function, I want the inputs to be real numbers and I want the outputs to be real numbers. If for some reason they're not real numbers, then it's, for our class, it's not going to be a function, or we'll have to change what numbers are going through the function, like restrict those values so that it can be a function that maps from real numbers over to real numbers. I'm going to keep explaining that today. Okay. So we're going from real numbers to real numbers. Y is sometimes called, or it can be called, f of x. And a picture. So you have a set of inputs. Let's put x in here. You put x in your function. And that function goes to another set of outputs. Let's call the function f. So x goes through the function f and comes out as some value y, which is called f of x. I'm just going to leave it like that. And that set of inputs is called the domain. The set of outputs is called the range. And it's possible that The range is a subset of the real numbers, but since we use the real numbers this semester, your range will be a subset of what's called the codomain. So this could be all real numbers, and these are the numbers that your function actually has outputs of. Like, we'll do examples. Just to like extra emphasize this, we're using real numbers. So let's say your domain is the real numbers. And you have a codomain that's restricted to the real numbers. And some function, we usually call it f, but it could be g or alpha, some title. And then you input some numbers, we call them x values. You've got these outputs, but the specific outputs from your function might not always be all real numbers. So it might be a subset of the reals or the whole set, depends. Oh, and then when we kind of talk about this, so your domain is real numbers, your range is a subset of the real numbers, which means f maps from the reals to the reals. If your function has an output that is not a real number, like it doesn't exist, then we'll have to take that out of the domain. If it maps to a complex number, which is outside of the set, we'll have to remove that from the domain. Everything else is kind of just going to stay as a part of your, all the other numbers that do map to real numbers stay in the domain. Examples will help. Inputs need to be real numbers, outputs need to be real numbers. If that's an issue, you need to tweak the domain so that you have the right values for your range. Things to watch out for. So things that could be an issue from your function. Let's say your function f of x looks like the root of x. So I put 0 here, I have the root of 0, which is 0. That's a real number. 1 goes through the function f, it comes out as root of 1, which is 1. If you go towards the negative side and you put -1 in through f, it comes out as the square root of -1, which is a complex number. So when you have an even root of a number and you want it to be a real number, it must be positive. Otherwise, it's going to be complex.
X greater than 0, right? Right.
Greater than or equal to.
Yeah, x or equal to 0. Okay, yeah. But we're looking for domain and range, right?
We will. I'm just going to give you pointers first on
Because it says look for fx.
or like
So like, for example, if x equals 1, that would equal to square root of 1.
yeah, you're right. So 1 is in your domain and 0 is in your domain, but not like -1/2 or -1 or any negative numbers.
Okay.
So we will do actual domain and range, but right now I'm just giving you like common functions to like when you're looking at your function and you see a piece of that, you stop and think, I need to be careful. So if you see a square root, be careful about the value under the root being positive or greater than or equal to 0. If you see a variable in a denominator, you need that denominator to not be equal to 0 because we cannot divide by 0. I'm going to give this function a different name. We're going to call it h of x. The function h takes inputs x and has outputs of 1 over x. Or any number over x, 2 over x, 5 over x. The problem is you don't want to divide by 0. So you need x not equal to 0. Any number divided by 0 is called an undefined number, which means it doesn't exist. Okay, another one is ln of x, or any log. The log of log base, let's call it b of x. I'm pretty sure it's by definition that that x value needs to be positive. Let's say the function's name is g, and g of x is equal to log base a of x. Okay, again, I think it's from the definition. The base of your log and the argument of the log need to be positive numbers. I don't even think you can put 0 in there. So you need x to be greater than 0. All right, and then I couldn't think of any other tricky parts of functions, so I started to make actual examples. So for these ones, we will find the domain and the range and probably draw a graph. I'm just gonna make sure I don't keep you over class. Maybe we'll leave a few minutes early today. Just checking the time. $11:20. Okay, we're going to have f of x equal to x. All right, so this is a graph of, or this graph would be a straight line through the origin, positive slope. Okay, so over here, every input has one output. If you put in 1, you get out 1. If you put in 2, you have 2. Input of -5 has an output of -5. So we can put all real numbers through this function. And all of the outputs will be real numbers.
Would we be able to put
negative infinity to a positive infinity?
Yeah, it's the same.
Okay.
Thank you. On that note, if you write an answer on your homework or quiz or test, and it's not like exactly what I would say, but I understand what you mean, I would still give credit. Or if you have different notation, that's fine. Okay, and we're gonna do f of x equal to 2 over x minus 5. Okay, so you're putting in real numbers or a subset of the real numbers. And the outputs look like this. We don't want to divide by 0. 2 over 0 is undefined. So we need x minus 5.
So x needs to be something greater than 5.
Well, it cannot equal 5.
Yes. So x greater than 5. Right?
And also less than 5. But not
Oh yeah,
including-
less than 5. Yeah. Less than 5. Yeah, negatives work as well.
So we're gonna put it's like there's 2 ways to write this. You could put the set of x, and the bar says such that x does not equal 5. Which, by the way, you just like add 5 to both sides and you get x not equal to 5. Or the interval notation, you go from negative infinity to 5. Close it with a curly, with a soft bracket, union it with a set that goes from 5 over to infinity. And then the range is all real numbers.
Well, what does the range equal? The range equals fx, right?
Yeah, all the actual outputs from f of x, or all those f of x values.
So range always equals f of x, okay? And range is always going to be all real numbers, right?
No. The range is going to be a set, and it's a subset of the real numbers.
Okay.
So I wouldn't say that the range is f of x. You want to say more like f maps into the range. Let's see. Let's just play with this a little bit. I think we have some time. So let's put some numbers in here. Numbers except from 5. So let's put 1.
Wait, is that you? Is that an and or is that an or?
Or.
Okay. Just gotta make sure. Yeah, it's been a while.
So if you put x equal to 1, f of x would be f of 1. So you're putting 1 in right here.
So yeah, so 2 would be 2 divided by -4. That would be -2. So f of 1 equals -2.
Let's do this.
I'm sorry if I'm going too fast first. The other
That's okay.
students. Okay.
We put in 1 and you get out -2. And then let's put in another number.
2.
2.
That would be 2 over -3. That would be -2 over 3. 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 That would be - Well, shouldn't you put the negative between the 2 and the 3 and not just at the 2?
It could be, as long as it's somewhere as a part of your number, it makes it a negative number. It can be in
Okay.
the numerator, you could pop it in the denominator or bring it out front.
Because I think like sometimes like I think at some points like the negative when it comes to fractions sometimes it does matter, or I don't know. Does it really matter where the negative sign goes to in a fraction?
Not to me. Like
Okay, so they all mean the same. Okay.
here or here or here. Yeah.
Okay.
Okay, so we're going to send 2 over to negative 2/3. So after playing with this for a while, you might be more comfortable knowing that the range is all real numbers. At least that's what I feel the range is. So we're going to put range equal to capital R. You know, I think, never mind. I thought a graph would help, and it would help, but I'm not gonna take time to draw the graph. I think it's one of those ones. And by the way, a good place to have a free graphing calculator to take a look at your function is called Desmos. Desmos graphing calculator is on Google, and you can type your function in, and it'll give you a graph of that function, so you can just see it right away.
Oh.
Yeah. Desmos. Okay, we're going to try f of x. Well, let's call it another thing. Let's call it j of x is root of x plus 3.
We're so. Oh wait. So no, never mind. Okay, never mind. We find the domain first, right?
Yes.
Okay, just gotta make sure about that.
So you need the expression under the radical sign to be some number that's greater than or equal to 0. So subtract 3 from each side. X greater than or equal to -3. So those are the x values we can use. Those are the values that can be in the domain. So your domain is going to go from -3, including -3, over to infinity. Okay, the square bracket.
The square brackets equal, right? Equal or greater than, yeah. Something like that, yeah.
You can actually, yeah, I put the soft bracket, which means don't actually use -3, but you want the square bracket, which means you do have that number in your set.
Okay, yeah.
What happened to the radical?
This part?
Yeah.
Well, what you kind of take from that radical is what's underneath the radical. So
Yeah, I think you're trying to say that the radical. Wait, what do you mean by the radical again? My bad. The square root.
I think what would help is if we just put some inputs in. So let's say, so we know the domain now has to go from -3 to infinity. So let's try putting in -3. We can put in numbers greater than -3, like 0, 5, -2. So let's put this number in. Thanks for asking questions, by the way. X as -3 means J of X.
We kind of cannot hear you. I'm sorry. Yeah, it's all good.
-3. So J of X is J of -3. Split -3 through the function, and you have the root of -3 plus 3. So root of 0, 0.
Oh, the square root of 0 is 0. Okay.
Okay, cool. I'll just have to remember to. Thanks for the info about.
Yeah, or if you can, even though it may be quite costly, just buy a microphone or something. I don't know. I'm sorry. I'm not. I should not be doing. I should not say that. I should not.
I'll consider it because we're gonna meet on Tuesdays, so it might be
Yeah.
worth it.
Uh-huh.
Plus, by the way, another hobby of mine sometimes is video editing, so I am going to be getting stuff like that in the future anyway.
Yes.
So, okay, so we have this picture. The function's name was J. So J maps -3 over to 0. We're going to put in one more number, some number between 3 and infinity. 0. Actually, we're going to put in 1, x equal to 1.
Wait, this is not a fraction, so like it doesn't really matter. Wait, now I'm kind
You
of
could put in 1
confused.
half.
For the domain, it's just so. Oh wait, what happened if it's like -4? It'll be like -1 then.
Yeah. So
Wait, and that would be irrational, right?
that's a complex. So
Oh,
we'll do that.
okay, yeah. Because I wonder why, like,
Then J of X would be J of -4. So -4 plus 1, you have a -1.
-1. Yes. And -1 is outside of the domain, so
Yeah, that's a complex number, I.
oh,
And
okay.
we're staying in the real numbers. We're not going to the complex numbers.
Oh, so when you try to find domain, you're trying to keep it at real numbers, right?
Yeah, so that's why
Okay.
you want to get rid of this one.
Okay. That makes sense. Yeah.
Because J would map -4 from, which is real number, maps that real number to that complex number. But we want our functions to map real numbers to real numbers. So you have to go
Okay.
here and restrict the domain.
Okay, so the main objective of find domain is to find numbers that make that only gets real numbers and no like irrational numbers. Something
Yeah.
like that.
And
Okay.
also no, not irrational. You want to say no complex.
Okay, no complex numbers. Okay.
Or imaginary. And the other time you look out for values that can't be in the domain is if it's an output that's undefined. Some number divided by 0 or something.
Yes.
Okay, let's see if we can do one more. A few more that are kind of easy. We did the straight line. Let's do a parabola.
The range always stays the same, right?
Oh yeah, this range, let's see.
It always stays the same, right? Or is it just like always 0 and up?
No, the range might change. And actually, let me go back. I didn't put the range. Domain, -3 to infinity. The range. Let's see. Trying to think now. So let's see, we put in -3 and we get out square root of 0, which is 0. And you put in negative. So your range here, I think, is going to be from 0 to infinity. And actually, we'll back it up here. Maybe we'll go to Desmos together and look at the graph. So the smallest x value you can put in is -3, which gives that output of 0.
Then I'll be 0 to infinity then.
Over.
Yeah.
I think the graph would help, but actually, instead of like making this confusing, we're going to stay at the whiteboard. So if you want to see the graph, the domain are the values in the graph that are kind of left to right on the x-axis, and the range is going up and down for your outputs on the y-axis. So in that function, there's no radical, there's no log, there's no denominator. So there's really nothing to look out for. I would just maybe, for getting started, throw some inputs in there, check out the outputs, or you can use your graph. Again, your graph, you want to find, from your graph, you want to use the values that go left and right for the domain. So you can go from negative infinity to positive infinity.
Yeah. Wait, wouldn't the domain be infinity and negative? I mean, infinity negative to infinity. Yeah. Okay. Yeah.
And then the range is the y values from your graph. So you can start at 0 and you can go up to positive infinity. So that would be a subset of the real numbers. Not all real numbers, just the positive part, including 0. All right, I think we're going to end there. When we come back, I might do a little bit more about functions, and then we're going to finally get into chapter 2.1. I plan to post homework 2.1 tonight, so that way tomorrow you can start to work on it using the notes. Okay, so that's it for today. Stay if you have questions or if you need help, or you can meet me at the office hour meeting